Not what I meant, not what I meant. Here's what I want. Okay. So there we go. Having a hard trouble. Okay, there we go. Relations. Alright, so we were dealing with relations and functions. Who can tell me the difference between a relation and a function? You're close. So it has, the X is repeated. Okay. So technically, Joey's correct. He is correct. A relation, the definition is just a set of ordered pairs. Well, it didn't look too good. Oh yeah. A set of ordered pairs. And we don't care anything about what those numbers are. They can repeat, they can be the same, they can be not the same, whatever. It's a bunch of ordered pairs. So if Joey tells us what a relation is, what's a function? Okay, anybody else? Relation and a function. Anybody else? You did it yesterday. How did you tell what a function was and what a relation was? Linda, what you got? You what? What repeat? But a specific number. The X. None of the X is repeated. So when you had let's see, you had a set of ordered pairs like 1, 2, 3, 4, and 5, 6. Did any of the X's, where's Luke? Oh, there he is. Did any of the X's repeat? No. So that's a function. Alright, then we did another way, we called it a mapping, where if it's on the test, they're going to have these circles on it, but on the study island it didn't have the circles. So they had numbers in here like 1, 2, 3, 4, 5, 6, and they drew arrows. And it looked something like that, except they didn't have the green circles around them. Is that a relation or a function? Why is that a relation and not a function? Let's call it just because what? Yeah, you do. Because what? Not exactly. Not that they both go to the 5. They do both go to the 5. You're right there. But the 5 is the Y, but I don't care about the Y. You want to add it?
When you put the line there, each number don't have a line to it? Don't have a separate line to it?
You are correct, but I'd like to hear it in different ways. No, Lord, no. Has nothing to do with the line there well. What did we just say right here? On a function, what can't be repeated? The X's can't be repeated. Are any X's repeated right here?
No.
Well, that 1 goes to that 4, and that 1 goes to that 5, is it not? So if I wrote all of these out, that would be 1, 4, 1, 5, 2, 5, and 3, 6. Are the X's repeated? Yeah, the X's are repeated. So this is not a function, it's a relation. And then we did one other thing where you were given a graph. Is that a function? What was the one thing we had to do for that? The vertical line test. Does it pass the vertical line test? If I draw vertical lines down through here, does it ever touch the red graph more than once? No, so it is a function. Alright, then we talked about, well, I should have been this before, but the domain is the what? And the domain and range. The domains are the X's, the range are the Y's. And let's see, what else is it? Then we did, we talked about function notation, where I said that was, you read that as f of x, and function notation was the same thing as y, no matter if it's at f of x or g of x or h of x or whatever, that's the same thing as y. So then we did, alright, if they gave you, f of x equals 2x plus 3, what is f of 4? And what did you do with that 4? You plugged it in where there was a x, right? Okay, so then we did 2 times 4 plus 3. That was the second part. So the first part we did 2 lessons yesterday. One was functions, and then this one was the evaluated function. So you had 2 easy 100s. And a lot of you did great on that. Alright, so now today, we're going to go into interpreting functions, which is looking at them in real world situations and describing parts of these equations. So let me go back into this. We've talked about linear equations. What's our equation we use, the form we use most in linear equations? Right, okay, that's supposed to be. And m is the what? M is the slope. That's the slope or the rate. And b is the starting point, the initial point, the starting point. But on the graph, it's the what? The y-intercept, okay? It's the y-intercept. We talked about that one over and over. Then we've talked about quadratics. There's 3 main things we've done. Linear, which are lines. Quadratics, anybody remember that form we always talked about? X squared plus bx plus c. And what in there was the starting point? C is the starting point. So B is the starting point here, C is the starting point here, A tells us whether it opens up or down, whether it has a max or min, and then we worked on, do you remember the last one? We had 3, linear, quadratics, and what our last one is? Exponential. And that's where it starts really slow and goes up really fast, or it starts really high and decreases really fast. So, does anybody remember that one? A times b to the x. A times b to the x. And which was the starting point on that one? A is the starting point on that one. So A is the starting point. And remember that B, that's either a 1 plus R or a 1 minus R, whether it's increasing or decreasing the rate. Alright, so now, back over here to this. Alright, so pizzeria charges a $2.50 delivery fee for all deliveries. And no matter how many pizzas you order, they're going to charge you $2.50 to come to their house, or them to come to you and bring you the pizza. Alright, and $5.99 for each. Keyword, we discussed this over and over and over. The rate. That's the slope, the filling piece. For each medium pizza order, tax included. The following equation represents the total cost Y, so cost is Y, for a customer who orders X medium pizzas and has it delivered. So I gave you the equation here. What does the y-intercept represent? This is a very good EOC question. A very good EOC question. So we just talked about over here. We're on a linear form. First of all, you gotta know which one is the y-intercept, the $5.99 or the $2.50. The $2.50 is the y-intercept, the starting point. All right, well, what does that mean? What is a sentence that explains that? But how would you say that in a sentence? You're right. Not for every pizza do you deliver. For every order. For every delivery, it costs $2.50. So that's exactly what it's going to say. Alright, so if I come on here, you joining us today? Alright, so it says right here, y-intercept is the delivery fee. Alright, so now we got another one here. The linear model below shows the population of a town X years after 1980. What's happening to the population? Decreasing, because we know that is a, what kind of slope? Negative slope, it's a negative slope, it's going down. Alright, so according to the model, what was the population in 1980? We gotta be careful here. They're saying the population of town X years after 1980. So where is 1980 represented on this? Look at zero, right? So that's where we start. That's our starting point at 1980. But here's where they're trying to trick us. Does that line go up any further where we need it to be? No, it doesn't go up. But we've got three things we could do. We could find, because what they're asking us is that y-intercept. So there's three ways we could do that. You may know one of them. And because we're trying to calculate the y-intercept, so we agree on that part. Okay? So how are we going to find this y-intercept? Okay, we'll rise over. We could use this graph and count, like from this point to this point, we go up to left 3, right? So we could go up to left 3. There's that point. And we could kind of guesstimate. If I just drew me a quick sketch, and even though your test is online, you still get graph paper. Now, let me do this. Alright, so there's 0. This is kind of like 12,000 is right here. So that's that point right there. How much is this going up each time? 1,500. So if I go up again, I'm at 13,500. If I add 1,500 each time, or if I go up 13 or 1,500 again, and if I go up 1,500 again, so on and so forth. But where was that point? That point is at 4 and the one above there. So let me put that point on here. Alright, so if I go up right here, there's that last point that they had right there. That point. So if I use the rise over run, which is what you were talking about, I go up 2, and here's what I'm doing, going up 2, left 3. So if I go up 2, left 3, 1, 2, 3 would be over here, right? Okay, so if I'm drawing my line to connect those, and of course it goes on down to kind of like it's a straight line, what would be a good estimate for what that would be, that point? That's what we're looking for. 15,000 maybe? Alright, that might be a good, well we don't know. But what if we have available to us to utilize? Also, given this, could you find an equation that would give you the y-intercept? How do we calculate or how do we find an equation? Did they give us points that we could plug in? Yeah, so go to your calculator. They gave us the point 10. This is just like a table. They gave us these 2 points. They gave us those 2 points, 10, 10,500, and 16, 7,500. So let's put those in. So get your calculators out, and let's go to, let me clear everything out. I have no idea what I got in here. Alright, so I'm going to my stats and edit, and we're clearing. Remember, we're not hitting what? What do we never hit on this? Delete. Never hit delete. So we had 10 and 16 for our X's and L1. And I don't remember what we had over here. 10,500 and 7,500. Alright, so 10,500 and 7,500. Don't forget to hit it. Alright, so we got those 2 equations. Now we need an equation. How do we find it? What do you do? Stat, calc, 4. Y'all gotta start just remembering this over and over. Stat, calc, and we're doing a line, so we're doing the linear. So 4, you gotta remember this is saying, hey, we put our X's in L1, our Y's in L2. We're not really gonna graph it, so I'm not so concerned about storing it. But there's my equation. What's my y-intercept? Calculator gave it to me. 15,500. You get it right there for me. Is that not much easier than drawing a graph? Now, if this happened to be one of the calculator inactive, would this be a good way to try to get close to it? Yeah, that wouldn't be too. Now, that's not the way they did theirs, though. One other way. Anybody know? one is really a whole lot longer than what we did. First thing they did was find the slope. Using the slope equation. And so they found the slope. Then they took the slope and a different form, point slope. So they plugged in the slope and they plugged in one of those points and found the equation that way. They're not going to give you one like this on your non-calculator course. So what I want you to do is this. Anytime they give you points, plug those suckers in L1 and L2 and run in a regression, whichever one it is, doesn't matter. Alright, so, and you'll see, they got 15,500. Alright, now, moving right along. Okay, Maria's attending, I can't read. Maria's attending County Community College in the fall. I think I skipped this one a second walk. Each semester, the community college charges students $275 per class for $325 in fees. Technically, when y'all get to college, you don't pay by the class, you pay by the hour. So this class right here would be a 3-hour class, and multiply that times 3. That's how much you're going to pay, plus that to take one class in college. If you think you don't need good grades for your scholarship, Justin, this is useful. The function below represents Maria's semester cost, C of X, given that she enrolled in the next class. So what's her starting cost, no matter how many classes she takes? 3 sets. 3 what? 325, not 375, not 275, 325, right? No matter how many classes she takes, she's paying 325. How much is she paying per class? 275. That word right there was our hint, but that was our rate, per. Alright, so suppose, I don't even know what it asked. Suppose Maria draws a graph to represent her semester cost. Determine whether the graph is increasing or decreasing. Why in the world would we draw a graph? Is her cost going to go up or go down? It's going to go up. So is it going to be increasing or decreasing? Increasing. What else right here tells me it's increasing? Because it's slope. The slope is what? Positive. That's a stupid question. But anyway, what they will do is they'll give you this question and they'll give you 4 graphs to choose from. Now, they'll probably give you this one on a non-calculator portion, and they'll give you 4 graphs, and the first thing, 2 of them are going to cross at 325. That's your first hint. The other one might have a negative slope, which if I walk around, which I wouldn't walk around because I can't be in the test with y'all, I'd probably smack you upside the head for choosing something with a negative slope when it's positive right there. I walk up behind you, but I'm just thinking, use your brain. Y'all get in there and just start guessing. You know how to do this stuff. Oh. Please tell me what's the first thing you do. Put these points in your calculator. I'm not even reading the question. First thing I'm doing is putting these points in my calculator. So put them in there. L1, L2. Anytime you're given a table, that should be your first hint. You're given a table. 1, 2, 3, 4, 6, 12, 18, 24. So that edit where I'm going to go. Okay, 1, 2, 3, 4, 6, 12, 18, 24. So those are the things you should have. Now, before you get any further though, you got to decide, when I do my stat calc 4, or stat calc 5, or stat calc 0, I got 3 choices, a line, a quadratic, or an exponential. Think about this. Common sense wise. A turtle is walking over time. And does a turtle start out really slow and then go up really fast? No, a turtle does not speed up really fast. That's an exponential. Does a turtle start out really fast and then drop down to really slow? Okay? So it's not an exponential. Does a turtle speed up and then slow down? No, so it's not a U, it's not a quadratic. It's a straight line. Another hint, how much are these going up each time? 6. They're going up 6 each time. How much are these going up each time? 1. Right now, we don't even know, so we're thinking, back here on this calculator, I'm going to do stat calc what? 4. I'm doing a line, so I'm doing 4. Again, I'm not graphing it, I don't care. I just want to see the equation. So what's that equation? Y equals 6x plus 0. Do I really need a 0? I mean, that would make sense. Where's this turtle starting point? 0. What's the turtle's rate? 6 what? 6 meters per minute. I have no idea what it, oh, look. What is the value of the rate of change? What is that another way of asking you? What's the slope? What did that calculator just tell us? 6. So surely to goodness that is going to be, well, what do you know? 6. Just what they did. Oh, it's not. Hello? Hey. Hey, Joe, how you doing? Well, some are absent as usual. And we're still going over the lesson right now. Yeah, it'll probably be another, at least 30 minutes maybe. Okay? Okay, all right. Well, good. I'll just send them over. Yeah. Supposedly, home. Yes. No. Just let's see. Yeah. No, sure will. Yeah. All right, we're recording that now. Yeah, that's it. Yeah. All right, I will. See you later. Okay, Anita won $500 at a cooking competition. Oh, that's nice. So she decides to open an interest-bearing savings account. You know what that means? When you go put money in a bank, they give you an interest. That's how they make money. I'm going to give you the bank $500. I'm loaning them my $500, and I'm going to make money. Now, am I going to make a lot of money? No. But it's better than that money sitting at home underneath my mattress or something, because it ain't making any money there. So that's what they call an interest bearing. You get interest based on it. Compounded continuously, that just means it rolls over kind of, not literally, the money's not going to roll over, but anyway. We won't go too far into this. At a rate of 3.5%. All right, so where did this 500 come out? Well, first of all, what kind of equation is this? Linear, quadratic, or exponential? That's an exponential. What does that 500 represent? Starting point. Where did that 0.35 come from? That's the rate of interest. But remember, 3.5. How did it become 0.035? We divide it by 100 or move that decimal right there. 2 places left. So here it was at 3.5 and it got moved to 3.5. Alright, so what does the y-intercept represent? The y-intercept is the starting point. The initial deposit. How much did she initially deposit? $500. Would be what they tell us. The amount of Anita's initial deposit. There we go. Easy enough. Alright. Okay, community launches a waste disposal plan. To reduce the amount of waste each person throws out by 2% a year. So they decided we've got too much garbage in our landfill. We're going to start this new plan. And hopefully everybody's going to reduce their garbage by 2%. There's not like a whole lot of others. This year, each person threw out an average of 900 pounds. About every person in here threw out 900 pounds of garbage. How much that would be? 900 pounds. Okay? Which is the reason why we have all these recycling programs. 900 pounds. All right, the function below represents the average amount of waste each person will throw out after, this is key, X years from the launch of the program. So they gave you this equation. What kind? Linear, quadratic, or exponential? Exponential, good. Where's the 900?
Starting.
The starting point. Why is it 0.98? I had 2%. Why is it 0.98? Because it's 100 minus 2%, or 1 minus 0.02. Remember, we take that decimal and move it 2 places? That's where the 0.98, that tells you it's a decrease. Well, that makes sense. We're trying to reduce the garbage, right? So it's a decrease. All right, so the community wants to examine the amount of waste each person will throw out from 4 years after the launch of the program to 7 years after the launch of the program. What is the minimum amount of waste generated in this interval? All right, so we're reducing this, correct? Minimum. Should we use 4 or 7? What do I even do with a 4 or 7? We gotta decide that first. You aren't great at just looking at numbers and plugging stuff in and not having any idea or clue what you're doing. But what do you think we're gonna do with that 4 and 7? No. No. They gave us an equation. It has some value in there, doesn't it?
So, what's the one that's having in there?
Okay, so maybe here's what Justin's saying. Let's plug 4 in there and let's plug 7 in there. All right, but let's think about this logically. We want to know the minimum amount of waste. Minimum, smallest, right? Well, if we're going, now think about this. This is kind of got to get a little bit hypothetical here. If I've got the minimum amount, it's an exponential. Y'all told me it's an exponential, right? That's how I know it looks like that and not a line. The minimum amount. Am I going to do that right here? Let's pretend like that's at 4 and that's at 7. Which one's going to be smaller? The number at 4 or the number at 7? 7? Okay, so let's plug 7 in there then. So 900, we'll put out of this, so 900 times 0.98 raised to the 7th power. So there's our answer. You think that's it? Nobody's asked. Nobody's saying anything. Is that it? No. Why did they use the 4? Have I led you astray again? Yeah. The minimum amount of waste. Why would they do the 4? Read that explanation, see if that makes sense. Forget about that first sentence. The lower bound, that means the 4, the lower bound of the interval will represent the minimum number of users. Any ideas why they did that? Here's a hint. Anytime they're asking for a minimum, use that smaller number. So if they're asking for a maximum, use the larger number. Because I'm afraid I could stand here and try to explain this over and over, and some of you would never understand what I'm doing. So let me go to this one. See if you can tell me what to do here. Alright, college student launches a new social networking website. Somebody creates a new Facebook. And that would have been great to create a Facebook. The number of users is increasing at a rate of 27% per month. The function below represents the number of users after the website launch. So how many users did he have to start with? Oh, how many users did he have to start with? 23, starting point. It's greater than 1, it's increasing, because remember it's either, this number in here is either 1 plus or 1 minus, isn't it? So it's 1 plus, where'd that 0.27 come from? 27% right there. Alright, so the college student wants to examine the number of users on the website from 3 months after to 6 months after. Key, what is the maximum number? The bigger number. So which one am I going to plug into that equation? 6. Alright, good enough doing it. Let's just go down here and see what they do. Did they plug in 6? Yes. Okay. Now, we don't wanna comment on the lesson, we want to go to here. Yes, still wanna go to this. Thank you, sir. Alright, Alfred is saving money for a spring break vacation. He opened a bank account with an initial deposit of $72. Ain't not too much to start out with, does it? Better than zero though. So he makes equal deposits of $63. So he starts out with $72, and then every week he goes in there and adds $63. If when he first opened the account, his initial deposit was increased by $72, how would his 9-week account total be affected? How are we gonna do that? Alright, let's just think about this common sense wise. He starts out with $72, right? Correct? After 0 weeks. And it says every week after that he deposits how much? Let me back over. I got it. How much does he start out? $63. There we go. Alright, $63. So after 1 week, how much does he have? Now I got your calculator. What's 72 plus 63? I'm adding 63 each week, right? 135. Alright, after 2 weeks. Adding 63. Question. Alright, after 4 weeks, or 3 weeks. Oh, I'll have calculators and you have fingers and you not. What's 198 plus 63? 261 plus 63. 324 plus 63. 387 plus 63. 450. Are we all on the same? I gotta keep my lines straight here. So plus 63? What is it? 513 plus 63? 576 plus 63? 689. 639. Alright, so that's what he initially had. Now it says, alright, if his initial deposit was increased by $72, so instead of starting out with $72, how much did he start out with? 72 plus 72, right? Which is what? 44. Alright, now after 1 week, he still added $63, didn't he? So what's his, so plus 63? What's he got now? 207 plus 63? What's he got now? 270? I could go all the way down through here and figure this out, couldn't I? But did the amount that he changed, did his rate change? Do we still add 63 the same way? What changed? His initial amount, right? Alright, so what do you think? The account total would increase by 72, the account total would increase by 711, would increase by 648, or by 144? Well, since nobody's telling me, we'll keep on going. 4, 5, 6, 7, 8, 9, so 270 plus 63. So I don't know what's interesting over there, but you're spending a whole lot of time over there. What'd you say, Justin? Who said it? Somebody said it. 333 plus 63. 396 plus 63. 459 plus 63. 5 what? 22 plus 65. 3. How would his 9-week total be affected? By a lot, I hear you say. What's the difference in those two things? $32. Did anything change? I think the only thing changed, so if we try 8, all that work y'all did. Oh, well, that's it.
Yep.
All right, so now Bradley opened a savings account with an initial deposit of $10. After 1 month, he deposited twice the amount of his initial deposit. And the next month, he deposited twice the amount he deposited the previous month. If this pattern continues, which of the following graphs represents the deposits Bradley made? Now, let's think about that. Remember when we started exponentials and we did the penny problem? Okay, if you started out with a penny, and I increase it every day for 31 days, how much are you going to end up with at the end of 31 days? How much did you end up with? Like $10 million, right? It increased a whole lot, right? So because we doubled it. I said if I double it, the amount, go back up. So is doubling not the same as twice? All right, so this should be an exponential. Let's see all 4 graphs. So are all 4 of these exponentials, do they grow really fast? Yeah, so that can't really help us any. But we know it starts at $10. Do they all start at $10? Does that one start at $10? No, so that one's not it. Does that one? Yeah, does that one? No, so we're looking at these 2. All right, so if you have $10 when you first start, how much are you going to have the next time it doubles? 20, all right? So does that one go to 20? Does that one go to 20? Right there's 20. That's 20. The blue line's over here. Right there's 20. That's not 20. That's 20. So it should be W. So take it to W. Alright, next question. Alright, so we've got, what kind of equation? Exponential. What's the initial amount? 11250. An industrial embroidery machine. So when they bought that sucker, it cost $11,250. It's decreasing. Machinery decreases, like trucks, cars. They decrease in value the older they are. So it's decreasing. Where T is the number of years since the machine was produced, or purchased, I'm sorry. What does the y-intercept represent? The starting point, so is it the value of the machine after 3 years, the rate at which the value of the machine depreciates, the amount of time it takes for the value of the machinery 0, or the original value of the machine? Is it not the starting point?
Yeah.
The original value? Alright, so D, I hope everybody's paying attention. You have to be looking up here. Alright, Maria, plan to make a blanket from a rectangular piece of fabric. What is this? Linear, quadratic, or exponential? Quadratic. Say quadratic. That square right there, Jennifer, say quadratic. Put your chair down. She is considering altering the size of the fabric in order to make the blanket. Maria decides that the area of the blanket will be modeled by the following function. I can already tell you, just by looking at this, what the area of that blanket was before she started. Anybody know? I'm not reading anything else. 3,700, because that's the starting point. Because it says she's altering it. Well, this is the starting point. She's reducing it, which is why it's negative, and she's reducing it. Alright, if Maria does not reduce the length of the fabric, the area of the blanket will be 3,700 square inches. What length can the fabric be reduced so that the area of the blanket, so I can do that one all the time, will still be 3,700 square inches? If you reduce the length of something, and I don't change the width, alright, if, give me some paper out there.
the liens, this is the width, I don't care how it is, this is the liens, this is the width, right?
And it says, she reduces, if she does not reduce the length of the fabric, the area of the blanket will be 3,700 square inches. What length can the fabric be reduced so that the area of the blanket will still be 3,700 square inches? So you're telling me that if I reduce but my area is gonna be the same. You say? Try eight, Paul.
I told you it was wrong. I told you it was 4 inches.
How you get 12?
You don't say that.
Well, explain it.
Okay, well, I took 24, divided by that, and then I got.
You just took 24 and divided by 2.
Yeah, then I divided half of 24.
But I convinced y'all that it would never have the same area though, didn't I?
Yeah.
Hmm.
So that's how I got 12.
So what in here is tricking it? I didn't make that problem. Well, if I reduce the length, okay, so I cut it off over here, didn't I? I cut it off right here, right? So what if I throw it back on over here? I cut it back over here. It didn't say anything about the width, did it? So what do you wanna get? You wanna go with Tom's 12? You're going with 24, cause there's a 24 in the equation? Alright, so, I don't care, pick one.
I'm gonna go with mine.
22. Alright, let's see the explanation. Go to the explanation. Alright, now, here's what it's talking about. You're looking at the zeros, where it crosses the x-axis here. I'm not gonna go through all this, cause y'all never pay attention to it anyway, so. Just click off that and it's doesn't it. Oh, another one. Ooh. It's a quadratic, cause it's a square. Alright, let's see. The theater, I'll go with B now. The theater department at the university is presenting a spring musical. The department decides to offer a discount. How do I know it's a discount from looking at that equation? It's a negative. To a high school group who plans to purchase at least 20 tickets. The group's total cost is marked by the following function, where X is the number of additional tickets over 20. If the group's total cost when they purchase exactly 20 tickets is $1,440, then how many additional tickets can the group purchase and still pay the same amount? If the group purchases additional tickets, they never pay the same amount?
Yes.
What do you want with? B? You want with B? Martha says B. Anybody have any other decisions?
I think it's B.
No, we'll go with what Ashley says, B and C.
I think it's D.
D? Alright, let's try D.
You said,
Why D? Why D?
Because it's the right answer, Ashley, and I don't guess.
Oh, he's gonna stand the whole time. Where did 16 come from? Ooh, Lexi says 32 divided by 2. 32 divided by 2. Alright, go next one.
Yeah.
Alright, natural gas company charges a $20.32 connection fee. Alright, so they're gonna come out to your house and they'll connect it for $20.32 plus $1.90 per 8 cubic feet of gas heat. In the winter, peak usage month, November through February, they charge each customer a peak usage charge of $18.91. If a family uses 104 cubic feet of gas, how much will their bill have increased because of the peak usage surcharge? If a family uses 104 cubic feet, well, how much, if they use 104, it says they get, up top it says they get $1.90 per 8, right? $1.90 per 8. Now, well, how many times does 8 go into 104? 13? Alright, so Shane says 13. So how much would they pay? $13 times $1.90, right? $24.70. Alright, so if they were gonna pay $24.70, but the company says, nope, the maximum we're gonna charge is $18.91. What do you think? Alright, let's go through it again, just make sure. Natural, they're getting charged $20.32 for connection fee, no matter what they use, right? Plus $1.90 per 8 cubic feet. So, if a family uses, what do you think? You think D? Why D? Well, where would you get D? Look at your numbers, where would you get D from? Yeah, okay, so on the D, the connection fee, they've gotta pay this plus that, that's where that's coming from. Okay, so that's where that's coming from. What do you think, Colin? Any hints to these young lads?
Still trying to figure out why it says increase. If they're gonna charge them $18.91 no matter what, and they're not gonna go over that, so they still have to charge them the connection fee?
That's the key there.
Because they're not connecting it.
They only got a connection once, right?
Yeah, they're only connecting it once.
So does that 2032 have anything to do with it? So no matter what, they're still paying 2032. So we're going with D? Or D? D? Alright, just click D and let's see.
Told you it was D. I told you it was D.
Alright, who wants to guess now? D? Try B. Go to the explanation. Alright, look, here's where they started at. A normal monthly charge. Notice, normal monthly charge, $1.90 plus there's the connection fee. So that's what they're gonna pay 13. Where did that 13 come from? Where did the 13, shut your mouth. Where did the 13 come from? Didn't Cheyenne tell us a little while ago, 140 divided by 8 is 13? Yep. Okay, so that's where the 13 came in. So on a normal month, they have that. But on this one, they get the $1.90 times the 13, plus that connection charge, and there's that one. So then when we subtract those two, which is what they did here, that's where the $18.91 came from. Alright, next question. I like these, these are easy. Alright, temperature on Monday in Dallas decreased. That's a negative, it went down. And now it's decreased by 5 degrees every 2 hours between 6 a.m. and 4 p.m. If the temperature at 6 a.m. was 55 degrees, which of the following graphs represents Monday's temperature? Well, first of all, alright, tell us. Why are the two bottom scroll? Why are the two bottom ones wrong? Because that's an increase. Very good observation. So we know we have just gone from 25% to 50% guessing. Alright, so the top two. So it says it starts where at 6 a.m. 55 degrees. Starts at 55 degrees. Now, are the graphs the same in every other aspect? Do they all count by, does this one count by tens on the Y's? Go from 6 a.m. to 4 p.m.? Alright, but it says it starts at 55 degrees. Does that one start at 55 degrees? No, it does not. W? Yay! Alright, Jolly or Jolie or whoever. Somebody's babysitting. She charges a base fee of $12 plus $6 per hour. If she decreases her base fee by $4, how are her earnings affected for a babysitting job of 6 hours? Let's think about this logically. if she goes to somebody's house for, 6 hours, she's gonna get charged, or she's gonna charge them 6 times 6, right? So 6 hours to $6 an hour, how much is that? 36, plus a $12 fee. $48. So normally she's gonna say 48. So now she's gonna say, all right, you know what? You're complaining. I'll give you a base fee of $4. So now instead of 12, her base fee is 4. So she's still getting $6 an hour, right? So 6 times 6 is 36. But 36 plus 4 is 36 plus 4 is 40. So up here she charged 48, down here she charged 40. What do you think?
I thought you charged 4 for every hour.
Her base fee. Read. Base fee. Base fee. It doesn't say she's changing her per hour amount.
Okay.
So Luke says A.
No.
I'm gonna kill myself.
What's not supposed amount? So what's wrong here?
I know this. There you go, Justin.
Somebody got the,
It doesn't say her base fee decreased to 4. It decreased by 4. So what does she really charge them? $8. If I charge you $12 and I say I'm going to decrease it by 4, how much am I now charging you? 8. Be careful. 1 2-letter word there. So really it should be B. Be careful. Alright? What did I tell you? A table, what do you do? Okay, but stop. Let's read this. The table represents the population of a community X years from 2000. What does the y-intercept represent? Did they give you the y-intercept? Yes. The y-intercept is where x is 0. Is that not x is 0? Okay, so is it the number of years it takes the population to reach 0? The population of the community in 2000, the rate at which the population, that right there says big blowing little whistles in there. The rate is not the y-intercept. Or the population of the community in 2005. D, the population of the community in 2000 when it started? Probably so. Last one. What kind of equation is that? Exponential. Atmospheric pressure at a given altitude in feet above sea level. Above sea level. Can be approximated by the function. They give you that big long thing. For the values of x between 0 and 32,800, what does the y-intercept represent? I don't care what values they give it to you. What does the y-intercept represent? The starting point. So what does that mean in this context? So you gotta be careful here. The starting point they have right here is this, correct? But this also says above sea level, correct? So are we looking at above sea level? A rate? At sea level? Number of feet needed for atmospheric pressure to reach 0 millibars? That has absolutely nothing to do with anything. So I'll tell you, it's A or D. Which one do you think? Anybody say D? Those of you that are paying attention? You say D? At sea level? At sea level? Alright. Alright, well, so let's go with A then. Since everybody thinks it's A. All I did was point out at a given altitude in feet above sea level, this is the starting point, and I said it's either this one or this one. So what do we think? How many say A? How many say B? Alright, more people say B, so we'll know it's B. Oh. It is B. Now you gotta pay attention to those little words there. Alright, next question, I think that's it.
It is.
Okay, so now, you've got 10 questions. Remember, don't just start going through that and guessing. Do not start going through and guessing. Joey, do not come to my class without your Chromebook anymore. You know you need it every day. No, you do not. You have it? Alright, get it out and go on. No, you cannot. Not right now. You can get your Chromebook out. You